Welcome back. So we're talking about solving rational expressions, and sometimes that requires doing a little bit of like adding, subtracting, multiplying, or dividing ahead of time. And what I really want to be careful about with these is sometimes we get answers that we think might be true that actually aren't necessarily true. And we got to be very, very careful about that. And so I want to talk about extraneous solutions today, and all of the problems that you see today are going to have extraneous solutions. The difference is that not all problems like this do. And so sometimes you don't run into this problem, but since we want to practice it today, all of the problems in this video will contain that. So we're going to be starting to solve, and the first thing I want to be able to do is get rid of this common denominator that I'm starting to see. So I'm going to multiply by x minus 2 on this side and multiply everything by x minus 2 on this side, and that's really important. So the x minus 2, they're factors on the numerator, and the factor on the denominator cancel out. But this chunk of stuff has to distribute both to the 7 and to that 10, and so we'll kind of clean it up here. So we've got 5x is what's left over on the left is equal to 7 times x minus 2, and then plus 10 times x minus 2, all of that being divided by x minus 2. Now, you'll see that those are factors, and yes, they are a fancy version of multiplying by 1, and so they eventually cancel out. And, 7 has to distribute, so we're just kind of solving for x at this stage. So 5x equals 7x minus 14 plus 10. These are like terms, they can combine, so 5x equals 7x minus 4. We're solving for x, so I guess I'll subtract 2 or 7x. Subtract 7x from both sides. So I'm left with negative 2x equals, the 7's cancel out, negative 4. And then leave myself more space. Divide by negative 2, divide by negative 2, negative and negative is positive, so x equals 2. So we only got one solution, and that's okay too. I know in some of our previous videos we've gotten multiple, but now we need to go through and check. We need to check to see if I substitute x equals 2 back into the original problem, will it cause me problems? And problems, I mean, will the denominator be 0? Because that's like impossible to do. So we'll start, I'm going to just recopy the problem. X minus 2 is equal to 7 plus 10 over x minus 2. And what happens when we plug x in everywhere? Well, we're going to run into lots of problems. And I hope that you see that we're going to run into lots of problems. 5 times 2, well, that's not really a problem. 5 times 2 is not a problem because it's 10. But if I do 2 minus 2, we got problems. And again, over here, if I do 10 over x minus 2, where x is 2, we also run into problems because this equals 0, and also this equals 0. We got bad news for number 2, bad news for x equals 2, because that's not a solution, right? We call it x minus 2 is an extraneous solution, extraneous solution. So this problem doesn't have any solutions to it except for the extraneous one. Some might have one extraneous solution and not another. We'll talk about that here in the next one. So let's talk about this. If you need to pause and rewind to really dig deep into the previous problem, please do. I really want to make sure that you're understanding what's going on in each of those. So step 1, we want to get rid of these fractions because you and I don't love fractions together. So we're going to, it looks like the denominators that we're dealing with are x minus 3 and 4. So we're going to multiply by 4 times x minus 3. Maybe I'll do that in a different color. We're going to multiply by 4, and we're going to multiply by x minus 3, and that's got to go to everything, right? So that stuff has to go to the x, and also has to go to this other x. But then we got to do it here on this other side, so we've got to multiply. I wish that I left myself a little bit more space. We've got to multiply by 4 times x minus 3, and that's going to be multiplying by that stuff. Okay, so kind of cleaning this up, this is going to be 3 times 4 times x minus 3. So 3 times 4 times that x minus 3 biz all over, I'll do that in blue, all over x minus 3 equals x times 4 times x minus 3 all over x minus 3 minus x times 4 times x minus 3 over 4. Okay, so this is really nice because it's all multiplication. It looks like, there's lots of parentheses out there, but all it is just telling me that these are multiplication. And so I'm going to go through this, and we're going to cancel things that cancel out, right? This is a factor. All of the denominator cancels out with the factor of x minus 3. All of the denominator here cancels out with this factor of x minus 3. And this 4 is just multiplied by 4, and so those cancel out. And we're left with 12 over here, and x in the middle, x times 4, x times 4, because the 4 is still there, minus, and then we're left with x times x minus 3. Okay, this is all about kind of cleaning up this solving. So 12 equals 4x, and then this is negative x gets distributed both places, so negative x squared and positive 3x. So we'll combine like terms, and in fact, we'll just go ahead and I won't do that quite yet, but we combine like terms, and we're manipulating these so that we can eventually factor them. So we got 12 equals 7x minus x squared. I'm just going to add x squared to both sides. Add x squared to both sides, so x squared plus 12 equals 7x. Subtract 7x. Subtract 7x, so x squared minus 7x plus 12 equals 0. We're going to factor, and maybe you're really fast at factoring and don't need to, draw it out, and at this point, that's going to be okay, but I know that this ends up being x minus 3 times x minus 4, because negative 3 times negative 4 is positive 12, and negative 3 plus negative 4 is negative 7, so it satisfies our needs. I'm going to use, so you could also use the quadratic formula if you wanted to. I just find factoring a lot faster, so we'll use the zero product property. X minus 3 equals 0, or x minus 4 equals 0. So add 3x is going to equal 3, or add 4 to both sides, x is going to equal 4. All right, so I told you everything we're doing today is going to have extraneous solutions. So I'll just quickly run through all of this. We got rid of the common denominator by multiplying by 4 times x minus 3. We had to distribute that to both sides. We canceled out things that were common so that we could kind of clean it up. And then we had to solve this quadratic for my x's. Now we always got to check. I'm going to do the check off to the side. We got to check. So if I go back to the original problem, which was 3 over x minus 3 equals x over x minus 3 minus x over 4, I hope that you see quickly that the only problem we're going to run into is this and this, which happen to be the same thing. And the dire problem is that, well, x can't be 3, because if x is 3, this is going to be 3 minus 3. Big problems. Big problems. So we can see instantly that x cannot be 3. When x is 3, x equals 3 is an extraneous solution. Let's see if I can fit that. Extraneous, let me rewrite that because I think you want to write it out, is an extraneous solution. However, we've got good news. X equals 4, right? X equals 4 is a solution. Because if I plug in x equals 4, I don't run into that divide by 0 problem. All right, so in this video, I've got one more. I'm going to kind of pause. I'm going to strongly recommend that you try it before you watch me do it, and I'm going to kind of chunk it out. So take a moment, pause the video, do this problem, and I'm going to do it in just 30 seconds. It'll kind of show up line by line by line. All right, if you have not yet paused the video to try this problem, please go ahead and do that. I'm going to show it line by line and pause the video as I go. So I'm multiplying by x plus 2 and x minus 2 to get rid of those denominator pieces, and then I'm going to distribute. So I distributed to each piece, and I tried to show the distribution here in red as best as I could, and my next step is going to be to cancel things out. So now that I've canceled things out, I'm going to clean it up. I'm just going to clean up this multiplication and what we've got. And if you look really carefully, it's super nice. It cleaned up quite well, actually. So I'll say, hey, like these are like terms, they cancel out. And it looks like I've got 2 x's, and that equals 4. Divide by 2, so x equals 2. That's kind of handy. Now, if x is 2, is that a problem? Go ahead and spend a moment and check. Hey, is x minus 2 a solution, or is x equals 2 an extraneous solution, like something that won't actually work when we substitute it in? So decide that for yourself. I'm going to actually zoom out and leave myself a little bit of space to do it off on the left. Pause the video if you want. So I copied the problem. I'm going to check. When I substitute x equals 2 into that, does it work? Yeah, it does, right? So it does actually work, right? Because 1 over 2 plus 2, that's 1/4, and that works. Does it work here? 1 over 2 minus 2. Problem. So x equals 2 is an extraneous solution simply because of that. Like, we can go on and convince ourselves that if 2 plus 2, that's 4, times 2 minus 2 is 0, well, that's also a problem. But you just need one problem to stop and say, hey, like, this is an extraneous solution. Bring your questions if you have questions. The purpose of this is to give you some time to kind of slow down, review, take notes at your pace. So thanks so much for watching. I hope this video kind of got you ready to think more about extraneous solutions. We'll practice a little bit more in class.